So tonight we're going to take a look at what is a function and how can I tell a relation is a function. And so we'll take a look at the definition of a function. We'll take a look at how a relation and a function are related, and some of the tests that we can do to decide whether or not we're dealing with a function or just a straight relation. So with that said, let's get started. So here you can see we have a picture of a circle, and I've drawn some of the points, but we need to be aware that as this circle goes all the way around, there's points here too. There's two, I don't know, maybe we call this 2, -1 that fits right here. And there's lots of different points that go around. And if we were to take those points and put them in a table, you'd see 0, 3, 3, 0, 0, -3, and -3, 0. And you can also see here that 0 has two outputs. When we look at 0, it can either be a +3 or it can be a -3. Well, that's fine. That's a relationship. We have a relationship with the x and the y, and it generates a graph that looks like a circle. Well, where does a function fit in there? Well, functions are just special relations. Okay? So every function is a relation, but not every relation is a function. Just the same as every square is a rectangle, but not every rectangle is a square. So how do we tell what is a function? Well, a function has one output for every input. X is the input, what value we choose to put into the equation, and y is the output. So a function has one output for every input. So let's take a look at what I'm talking about here. We can take a look at a relation is a function by looking at the ordered pairs. So here we have 2, its output is 3. 7, its output is 12. 5, its output is 6. And 4, its output is 6. Each input has only one output. So this is a function. This next example, we have -3 produces related to a 2, 5 to 6. -3 also can be graphed with a y of 7 and 4 with a y of 3. So here -3 has two outputs. We choose -3, we either graph -3, 2, or we can graph -3, 7. In fact, we are required to graph both of them. So -3 has two outputs, therefore is not a function. Remember, for every input, I can only have one output. This input of -3 has an output of 2 and an output of 7. Now the second method is called the vertical line test. And what we'll do here is I'll show you some examples of graphs where we can tell whether or not each x input value has only one output value. So the way this works is that with the vertical line test, basically we draw a vertical line and we decide how many times do we cross the graph. And so we do a couple of checks, but every time I draw a vertical line, I cross the graph once. That means for this x value, I have only one y value. For this x value, I have only one y value. So I know that, is this relation a function? Absolutely yes. Let's take a look at this example. And then we have another graph, vertical line test. So we're going to draw vertical lines. We draw a couple of them. And so when I look at this x value, how many different y's are on the graph for this x value? Well, in this case, I have a y value here, and I have a y value here. And we can also check if we did it over here. I have a y value here and a y value here. So I can only have one y value for every x value that I have. In this case, I have 2. Is this relation a function? The answer is no. Okay, one more test. Vertical line test. Do it a couple times, but I really only need to do it one. So for this x value right here, how many y values do I have? Looks like I have 2. Is this relation a function? No. All right. So I think that's a good enough start there. And let's just pause here a second. Let me take you back. Okay. So let's go back into here and see where we're at. So the second method is called the vertical line test. We've already done that. And then finally, I'd like you to think of a function as a machine. You give it an x value, and it gives you a y value. So how do we write this function machine? Well, we write f of x is equal to 3x plus 2. We choose the x. Let's choose 1. And it generates 3 times 1 is 3 plus 2 is 5. So my ordered pair is 1, 5. We choose the value to put in for x. This time I'll choose 3. 3 times 3 is 9 plus 2 is 11. So we write the function. We say the function of x equals whatever. So when we say that, we're saying the function of 4. 4 goes into 3 times 4 is 12. 12 plus 2 is 14. So we write the annotation. If I asked you to find f of x equals 3x plus 2, find for f of 4, I'm asking you to replace x with 4. I could have easily said replace x with 12. I can tell you to replace x with y. 3y plus 2. So that's a little bit more complicated. Anyway, I hope this video has helped you this evening, and I will get back to you and we'll talk more tomorrow. No post-video quiz. Good luck.